Geometry transformations. Rotations. Rotations about the origin. Remember, the origin is where the x and y axis meet, 0, 0. In grade 8, when we do rotations, we're only doing them around the origin. We're going to start off just by doing a rotation of a single point before we start rotating a shape. So suppose I had a point on my Cartesian plane here at 6, 4. I'll call that point A, 6, 4. And I want to rotate it 90 degrees. I have a compass. I'm going to put it in place, and it'll help us to see how the rotation works. So I'm going to go ahead and I'm going to turn this 90 degrees and stop more or less when I get to 90 degrees. And I'll put a point there. We're going to call that A prime, and A prime we can see is located at -4, 6. I'm going to continue that rotation now for another 90 degrees. And we've put another point there, and we'll call that A double prime, and its coordinates are -6, -4. Continuing the journey a little further on the rotation, another 90 degrees, which takes us to 270 degrees in total. Another point there, we'll call that A triple prime, and its coordinates are 4, -6. So this was our 90 degree rotation here, 180 degrees here, and this was 270 degrees. From this we can get a general rule that says any point that has coordinates x and y, if you do a 90 degree rotation, then the new coordinates of P prime, you switch the positions. So you see we went from having a 6 and a 4 over here to now having a 4 and a 6. So you switch the x and the y positions. So you now have a y here and an x there, and then you put a negative in front of the y. If you want to do a 180 degree rotation, then P prime is going to be -y, -x. And for a 270 degree rotation, P prime is going to be y, -x. So for rotations about the origin, this is the simplest way of figuring out what each of the points or vertices will be after they've undergone the rotation. Now let's go ahead and look at a more complicated shape. This time we've got a triangle. We're going to rotate the triangle 90 degrees. So remember that means we're rotating this way, and let's see how it works when we apply that rule. So we're rotating around the origin. It's important to note the point of rotation. And since we're rotating 90 degrees, we know that our general rule said P of x and y for 90 degree rotation will give us P prime of -y, x. So if we look at our 3, 2, that means our A prime will be -2, 3. Plotting that on our Cartesian plane, we go -2 and up 3, and that gives us A prime. Now let's look at B. It's 9, 4, which means B prime is going to be -4, 9. Plotting that, -4 up 9. And that's our B prime. And finally, vertex C at 8, 10. That tells us then that C prime is going to be -10, 8. -10 and up 8 puts us right there. Connecting up those vertices gives us the rotated image. And maybe we'll use our compass to check those out. Let's see how B rotates around. And we want to rotate 90 degrees. Oops, went a little too far. There we go. 90 degrees. How about C? Rotate it around 90 degrees. So we can see that each of the points, when we turn it 90 degrees, ends up exactly where the rule predicted they would be. So the key points to remember when doing rotations about the origin are that for every point with coordinates x and y, if you do a 90 degree rotation, P prime will be -y, x. For a 180 degree rotation, P prime will be negative x, negative y. And for a 270 degree rotation, P prime would be y, negative x. And rotations with a positive value are in the counterclockwise direction, which means that they're turning this direction.